Well, hello everybody, wherever you are in the world, whatever time of day it is. Welcome to this webinar, Our Future in the Balance, the role of courts and tribunals in meeting the climate crisis. My name is James Cameron. I'm your host, moderator for these 2 days. Liam will put in the chat how you find out about me, but in essence, I'm a barrister by training. I taught law as well as practice for many years. I wrote the first law review article on state responsibility for climate change back in the late 80s with my friend Derwood Zelke. And he and Philippe Sands and I started the Centre for International Environmental Law back in 1989. What interests me and what excites me very much about this program is that we are able to look between disciplines. I'm fascinated by the space between law and science, law and politics, policy, commerce and enterprise, and of course, finance. And we've got to make those connections if we're really going to understand how to make a transformation in our society, where increasingly the science has produced evidence, sufficient evidence for courts and tribunals to rule upon the application of the law. And that evidence has just got better and better over time. It's now closer to being able to provide attribution. It's possible, therefore, to move from general responsibility to specific liabilities for harms caused or failure to act. Many of the cases we'll hear about have become increasingly specific about timing, when a state needs to act in order to protect rights of its citizens. In fact, that temporal dimension is critical, and you'll see it throughout the program. How to match urgency, and you're about to hear more about that from Johan, with the delay that has been in place for so long, with governments failing to act sufficiently in a sufficiently timely manner to protect the rights of its citizens. Many of the cases have that temporal dimension. And that, of course, raises questions of intergenerational fairness, equity, and justice. We'll hear about that from presenters during the course of these 2 days. Many of the cases are also about abuse of power, whether in public or private hands. The law, the rule of law being used to challenge abuse of power. I was taught by Philip Allott at Cambridge that the law represented a will to perfection, a generalized will to perfection in society, in itself an ideal. And one of the things we'll want to look at closely is the separation of powers between law and politics. Where does power properly reside to make the transformation that we need to make in order to respond to what is essentially an existential crisis for humanity? And when we think about the role of law there, we need to think about it as a tool for change, not necessarily as an instrument for protecting the status quo, although it can be that too. So as we go through the program, tremendous speakers, big range, lots of opportunity, hopefully for you to contribute around the world, wherever you are. I will try and draw these strands out in conversation with our speakers for your benefit. You'll be able to contribute to, and we'll find in the chat various ways to respond. But let's begin where we properly ought to, with the science, with the understanding that we need to have about the nature of the problem we want law to help to resolve. And in doing that, it's my huge pleasure to introduce Professor Johan Rockström, Director of the Potsdam Institute for Climate Impact Research, Professor in Earth System Science at the University of Potsdam, and leading advocate for the role of science in understanding the climate problem. Johan, the floor is yours.
Thank you very much, James, and hello everyone. I'll be sharing my screen here just briefly, and there we are. Okay, I hope you can see that there. So what I'll do, just following exactly on James' introduction here, I'd like to provide you with a scientific update of the challenges facing humanity and how to navigate the future for our world on planet Earth in just 10 minutes. And the starting point for any such summary today must be based on what I would argue being the most important scientific message to humanity as a whole, namely that we have empirical evidence from observations that we have entered a whole new geological epoch, the Anthropocene, anthros for us humans, that the scale and speed and interconnectivity of human pressures on the Earth system have led to the conclusion scientifically that we are now, as humans, the dominating force of change on planet Earth. We're starting to hit the ceiling of hardwired biophysical processes that regulates the stability of the Earth system. Now, this is not based on hypothesis or theory or models. It comes from empirics. It is the hockey stick observations from the Industrial Revolution until today, which is the same timeline on all these graphs here, showing on the left hand the exponential rise on human pressures, and on the right hand, all the green graphs, the pressures on the Earth system from greenhouse gas emissions, loss of biodiversity, overpollution of nutrients, deforestation, and all parameters that really matters for human well-being and that regulates life support systems on Earth. Focusing on climate, we have the observations that last year was the warmest year on record, together with 2016. The last 10 years is the warmest decade observed. But not only that, we have now unequivocal scientific evidence that we have passed the warmest mean temperature on Earth since we left the last ice age. 1.25 degrees Celsius of warming is outside of the entire corridor of variability over the past 12,000 years. What happens at 1.25 degrees Celsius of warming? Well, the scientific red thread is that things are changing more abruptly than we had anticipated. What we're seeing right now in British Columbia and parts of West US with 49.6 degrees Celsius of warming, heat waves and forest fires is an amplification from 1.25, which is difficult to explain, but there is scientific evidence to show that in this case, it is very likely a combination of accelerated ice melt in the Arctic, changing the jet stream, which regulates weather systems in the Northern Hemisphere, locking in high and low pressure systems when you get wave resonance of the jet stream, which locks in weather patterns in ways that can explain, for example, the 2018 California wildfires and the European heat waves and fires, and could also be connected with the extremes we're seeing today. So a scientific lesson of precaution is that interconnectivities in the Earth system may give abrupt, unexpected outcomes. To the extent that we have to legally, but also ethically, start looking into what happened, for example, the kind of disasters that occurred recently with the Miami condo collapse. Now, we have been seeing evidence for decades of salt intrusion, how that undermines livelihoods for Bangladeshi farmers because of the 20 to 25 centimeters of global sea level rise we've seen so far due to our fossil fuel burning. But we have also warnings since decades of structural undermining of steel construction and concrete with saltwater intrusion in low-lying state origins, such as, for example, in the Miami Beach area. We cannot say that this is connected at this occasion so early after this disaster, but it's something that we need to pick into and really focus in terms of our analysis and in our legal practice of what are the risks we're facing when it comes to, in this case, posing a higher level of salt intrusion risk on low-lying societies around the world. And I bring this up because of a legal challenge we have, which is that climate change is a slow variable. And we have plenty of scientific evidence showing that fossil fuel burning leads to temperature rise, which leads to sea level rise. But sea level rise is a slow variable. So far, we've only increased sea levels with 20 centimeters, but we know that the last time we had between 1 and 2 degrees Celsius of warming, 125,000 years ago. The last time we had a warm interglacial, in between we had a 100,000 year ice age, the sea level on Earth was 6 to 9 meters higher than today. So we are committing ourselves to much larger outcomes than the impacts we feel on the short term. And our legal systems and our economic systems are not well suited to address this. But this is why we, for example, saw the Constitutional Court decision in Germany in May 2021, deciding that the Federal Climate Change Act is unconstitutional for the simple reason of pushing the responsibilities to future generations. And that has to do with this time lag in the climate science. But we are observing fast changes as well. This is a remarkable global mapping of what's happening with the glaciers across the planet. This is, scientific communities from field studies across the world showing in the depth of these red graphs the mass loss of ice from Alaska, Greenland, but all the way to, as you see also now, losing mass in the third pole, the Himalayas. And I bring this forward here just to draw two conclusions. One is that all ice sheets on Earth, Arctic, Antarctica, and inland glaciers are losing mass. But secondly, we are seeing increasing signs of losing mass faster in areas which have very strong connections to social impacts, such as the dependence of the third pole, the Himalayas, in Pakistan, India, Southeast Asia, and China. So here we have also a very quick connection between climate change and the legal stability in societies. I could spend many minutes and hours probably on the attribution issue that James pointed out. The science has come a long way in attributing amplification of extreme events due to global warming, never accusing an extreme event of being caused by global warming, but being amplified. This is now documented in a much wider way by the UN. So the World Meteorological Organization and the Intergovernmental Panel on Climate Change recently published the United in Science summary mapping out all the attribution evidence we have on extreme events at 1.25 degrees Celsius of warming. But what I want to spend the next few minutes on is really, where are we heading? Where are we heading in terms of the risks of undermining the stability of the entire Earth system? Now, the past 12,000 years are extraordinary. And here again is an extraordinary advancements in science from ice core data, both from the Vostok ice sheet in Antarctica, but also from Greenland, showing how we leave the last ice age 20,000 years ago and how we enter this remarkably stable state, which you see here in blue, that we define as the Holocene. On the y-axis here, you have global mean temperature. So the 0 point is always the pre-industrial 14 degrees Celsius point. So you see -4 and we're in deep ice age, 70 meters lower sea level than today. But look at the Holocene. This is 12,000 years of remarkable stability within a ±1 degrees Celsius corridor of climate stability on Earth. Why is the Holocene so important? Well, because before the Holocene, we were just a few million people on Earth. We were hunters and gatherers. We enter the Holocene and we start domesticating animals and plants, and off we go in the civilizational journey as we know it. And look at the spike, how we're heading towards a 3+ degrees Celsius world in a blink of geological time, crashing right through the Holocene corridor. But it's even more challenging than that. We have in the latest climate modeling, published just a year ago, for the first time been able to reproduce the temperatures on Earth over the past 3 million years, the entire Quaternary, the only phase of the 4.5 billion years of Earth's life that resembles the planet as we know it today. And look at the green line here. Not at one time for the past 3 million years have we passed 2 degrees. Again, the y-axis is global mean temperature, and 0 is the 14-degree pre-industrial temperature. So the corridor of life on Earth is extremely narrow. We've never been above 2, and at its warmest point, and -4 to 6 is deep ice age. This is, if anything, even more scientific support for staying well below 2, aiming for 1.5, and delivering on the Paris Agreement. But it's even more important than that, because why has the Earth system been able to stay within this narrow corridor? Well, it's not only because of the gentle stresses from solar orbiting. No, it's also thanks to the resilience of the Earth system itself. And here we have more empirical evidence to support. What this shows from the Global Carbon Project is the hockey stick of fossil fuel burning above the 0 line. So you see from 1850 until today, the hockey stick of release of carbon dioxide from fossil fuel burning in gray, and land use change in orange. But look at the dark green and the light green. This is the 50% uptake of carbon dioxide in oceans and natural ecosystems on land, meaning that the planet, the more it gets stressed under a resilient state, is able to absorb and dampen and cool our stresses on the Earth system. So it's only the blue wedge there that is causing the warming so far. So this is proof that a healthy planet tries to apply its biogeochemical process to remain in a stable state. But unfortunately, we're seeing more and more signs like this, indicating that we are losing the carbon sinks in nature. The Brazilian part of the Amazon has now, over the past 10 years, flipped over from carbon sink to carbon source. This is a great worry because we understand more and more that we have tipping points. And tipping points are in systems that regulates the stability of the climate system. And this was published also a year ago in Nature, mapping out the tipping elements in the Earth system that are showing signs of instability. And these are the 9 systems showing signs of instability. And you see here the Arctic sea ice, Greenland, the Amazon, West Antarctica. Not that they've crossed tipping points, but that they're showing signs of variability. And the key message here is really on the arrows in between these systems, that the science is now showing increasingly that they are interconnected, that when Greenland melts fast, releasing cold fresh water into North Atlantic, it slows down the Gulf Stream and the Atlantic overturning of heat, which impacts the monsoon over the rainforest, which can explain the rising frequency of droughts and forest fires, which also locks in warm water in the Southern Ocean, which can explain the accelerated melting of the West Antarctic ice shelf. So already at 1.2, we're seeing signs of change. That is why, to come to a close, we are at this urgency point. We need to bend the global curve of emissions, shown here in green, and land at a net zero world economy by 2050. We call this the carbon law. It gives us 60% chance of landing at 1.5, but only if we're able to not only bend the curve shown here in gray, meaning cutting emissions by half every decade, meaning a world reaching 50% cuts by 2030. That's the urgency point. But we also need to transition the food system from source to sink, shown here from brown to the orange wedge. And we also need to start scaling CCS and negative emissions to suck out carbon dioxide from the atmosphere, shown here in orange. And we also need to keep nature intact, shown here in green and blue, for oceans and natural ecosystems on land. And if we do all this, we have a 66% chance of staying within the life corridor over the past 3 million years. So you can talk of not only urgency, but you can also talk of a sustainability transformation. So I leave you with this, just, I hope, inspirational science framework, which is that now it's about human development and dignity and justice, represented here by the Sustainable Development Goals, within the planetary boundaries, meaning within a stable and resilient Earth system. And that's where I think we are starting to see the emergence of a redefinition of justice, that the ultimate definition of justice is that the current generation of adults on Earth that are kind of having the watch on the planetary system today must leave behind to the next generation a planet which is at a livable state equivalent to when the adult generation was born. That this is the intergenerational dimension that we're seeing in so many legal cases being brought forward as a new challenge for the legal system in the world. And with that, of course, it is to say that what you're doing is so important. And good luck with your deliberations during these 2 days. Thanks very much, and back to you, James.
Brilliant. Thank you so much, Johan. I mean, that sets us up perfectly. And the fact that you've owned that language at the end there of climate justice is particularly helpful. And we're going to move straight on